Hello, this is Abu Zar from Math Concepts channel. In this video, we use Math library in Python to find the coordinates of rotating a point around another point in two-dimensional space. Please subscribe to this channel to watch and learn more about conceptual mathematics problems. Let's consider point P in two-dimensional space. Let's consider center point C in two-dimensional space. Let Q denote the counterclockwise rotation of point P with angle theta around point C. Using the equation for rotating a point around another point in two-dimensional space, we write a Python function that finds the coordinates of rotated point Q based on rotating point P, center point C, and angle theta. Please pause this video now and open a Python editor and write the function to rotate a point around another point in two-dimensional space by yourself. As a hint, import math library in Python and define the rotate2D function that inputs rotating point P, center point C, and angle theta. Then use the equations for rotating a point around another point in two-dimensional space and return the rotated point Q. Note that you can download and install Python from its original website at www.python.org/downloads. Then you can use Python's default IDLE or install other Python editors such as Jupyter Notebook or Visual Studio Code to write and compile your Python code. You can also use an online Python editor and compiler such as Google Colab with the website link at colab.research.google.com. Google Colab has many installed Python packages and allows users to use GPU and TPU for problems with highly computational load, such as deep learning problems. Let's write the Python function that rotates a point around another point in two-dimensional space in details. In the video that is published in this channel with title Rotate a Point Around Another Point in Two-Dimensional Space, we showed that the coordinates of rotated point Q is derived as 2D rotation matrix times the difference between rotating point P and center point C plus the coordinates of center point C. To implement 2D rotation in Python, we define a function, call it here rotate2D, that inputs rotating point P, center point C, and angle theta, and outputs the rotated point Q. Expanding the matrix equation, we have xq equals to cosine of theta times xp minus xc minus sine of theta times yp minus yc plus xc. And yq equals sine of theta times xp minus xc plus cosine of theta times yp minus yc plus yc. Let's write these two equations in Python. We represent angle theta with parameter theta. To calculate cosine of theta, we use the function math.cosine of theta from Python's math library. To calculate sine of theta, we use the built-in function math.sin of theta from Python's math library. Point P has coordinates xp and yp. We denote rotating point P in Python as a list with two elements that are xp and yp. Center point C has coordinates xc and yc. We denote center point C in Python as a list with two elements that are xc and yc. And rotated point Q has coordinates xq and yq. We denote rotated point Q in Python as a list with two elements that are xq and yq. After defining each parameter and function in Python format, let's write the 2D rotation equations in Python programming language. We have xq equals to math.cosine of theta times xp minus xc line break minus math.sin of theta times yp minus yc plus xc. Note that we use backslash sign as line break in Python editor when the Python command is too long and we like to write the rest of the Python command in the next line. Also, we have yq equals to math.sin of theta times xp minus xc line break plus math.cosine of theta times yp minus yc plus yc. Now let's put the Python formatted 2D rotation equations into a Python function. A Python function is defined with keyword def, function name, input parameters of the function inside parentheses, and the colon sign. The rotate 2D function inputs rotating point P, center point C, and angle theta. It outputs rotated point Q. Note that all the command lines inside Python function must be indented with equal number of spaces. Here we use 4 number of spaces for indenting the command lines inside the rotate 2D function. In this video, we use sine and cosine functions that are defined in Python's math library. Thus, we need to import math library into our code. Point P is represented as a 2-element list. Note that counting the elements in a Python list starts from 0. xp is the first element of list P that is equal to P0. And yp is the second element of list P that is equal to P1. Note that we don't need to add semicolon at the end of Python command. As we have written 2 Python commands in one line, we need to add semicolon to the end of the first command, so compiler discriminates these 2 different commands. Center point C is represented as a 2-element list. xc is the first element of list C that is equal to C0. yc is the second element of list C that is equal to C1. We also represent rotated point Q with a 2-element list. Q0 equals to xq and Q1 equals to yq. Here is the Python function that inputs rotating point P, center point C, and angle theta and returns the rotated point Q. Let's see the performance of this function with an example. As an example, let's consider point P with coordinates 3 and 2 and center point C with coordinates 1 and 1. Let's consider angle theta equal to 90 degrees. We use our developed Python function to find the coordinates of rotated point Q, that is counterclockwise rotation of point P around center point C with 90 degrees. Note that Python functions math.sin and math.cosine input angle in radians. Thus, we need to change the unit of angle theta from degrees to radians. The perimeter of a circle is 360 degrees, that is equal to 2 pi radians. Therefore, theta in radians equals to 90 degrees divided by 360 degrees times 2 pi radians, that is equal to pi divided by 2 radians. Let's convert these mathematical parameters into Python language. For pi, we use constant parameter in math library denoted as math.pi. Thus, theta in radians equals to math.pi divided by 2. We represent point P as a two-element Python list with first element equal to 3 and second element equal to 2. We also represent center point C as a two-element Python list with first element equal to 1 and second element equal to 1. To find rotated point Q, we use our developed Python function rotate2d with inputs rotating point P, center point C, and angle theta. Let's print the coordinates of rotated point Q to the output console. Note that in Python 3 we use parentheses in print command. We obtain Q as a two-element list with xq equal to 1.1 times 10 to the power of negative 16 and yq equal to 3. Note that math library in Python approximates sine and cosine functions with high precision of decimal places. Here, approximation is more than 16 decimal places that shows xq as 10 to the power of negative 16 instead of 0. To represent xq as 0, we reduce precision of approximation by rounding it up to a lower decimal places. We use round function in Python with a lower decimal places of 5 to represent 1.1 times 10 to the power of negative 16 as 0. Let xqr denote the round of xq with 5 decimal places. We have xqr equals to round of q0 with decimal places of 5. Also, let yqr denote the round of yq with 5 decimal places. We have yqr equals to round of q1 with decimal places of 5. Let the two-element list qr denote rounded point q with first element equal to xqr and second element equal to yqr. Let's print the rounded rotated point Q into output console. Rotated point Q is shown as a two-element list with xq equal to 0 and yq equal to 3. Here is the complete Python code to find rotation of point P around center point C counterclockwise with angle theta. In our example, P is equal to 3 and 2 and C equals to 1 and 1 and theta equals to pi divided by 2. We obtain Q as 0 and 3. Here is also the complete code written in Google Colab. Please write the 2D rotation Python code and obtain the results by yourself. Thank you for watching this video. Please subscribe to this channel to watch and learn more about conceptual mathematics problems. If you enjoyed this video and find it useful, please press the like button to make it more visible for other audiences.